Hey, what's up, guys? This is Dr. Vivek Palipuram bringing you the last lecturette in ECPE 170 Computer Systems and Networks. In this lecturette, I'm going to show you, I'm going to give you some hints with respect to implementation of the randomization functions that you'll be implementing in lab number 11. By no means I will be giving you any complete solution, but I'll be dropping certain hints that is going to or that are going to help you implement the randomization functions. I'm also going to show you some common errors that students make when they utilize the stack inappropriately. So let's get started. Okay. So the randomization function that you need to implement is right here. You have two functions, random and range, and you have this function get random. So random and range, it initializes certain variables and performs some math operation here, and the percentage sign stands for the remainder operator, and it is performing all of these math operations using these variables that are unsigned integers. The random underscore in underscore range calls this function get random, which utilizes some global variables like mz and mw to perform some additional computations using bitwise operators and some multiplication. And then finally, it returns a result. And in this way, these two functions accomplish the task of generating some random numbers. So now let me give you some hints with respect to their implementation. So these are normal functions. You'll still set up their respective function stub. You're going to still push and pop certain registers that need to be saved. Specifically, if a function is a caller, and if it is using any of the T registers or the argument registers, it needs to save them onto the stack. If a function is callee, then it needs to definitely save the S registers that are being actively used by its immediate caller. At the same time, it should definitely save the RA register just to make sure that your program returns to an appropriate location after the function is over. So let me give you hints with respect to their implementation. Specifically, I'm going to give you 3 hints. So hint number 1. If you carefully notice in these functions, we are working with variables that are of type unsigned integer, uint32 underscore t. So in order to perform any operations with these variables, we need to use unsigned instructions. For example, subu and divu. In addition, these functions are also performing some bitwise operations. So you'll be using instructions such as and I, SRL for shift logic right and SLL for shift logic left. And you'll find those instructions on ECPE 170's webpage, and I'm going to show you where exactly they are. What I would like for you guys to do is carefully look into these instructions and make a careful note of the various operands that these instructions take. So this is hint number 1, making sure that you use unsigned instructions like subu and divu to perform these math operations, and paying careful attention to these instructions as to where the results are stored, and using the bitwise operators like and I and SLL and SRL. Hint number 3, or rather hint number 2, is as follows. One of the mistakes that students often make in this particular implementation is that they fail to store the value of mz and mw back into the main memory. This is one of the important tasks that this function getRandom is actually performing. Mz and mw, they are global variables, and if you notice here, these global variables are being changed. The function random in range is being called repeatedly in some sort of a for loop elsewhere in your code. So mz and mw, they need to be updated each and every time. Should you fail to update them, should you fail to store the values of their respective registers back in these memory variables, then you will find that your randomization function is producing just the same value. So that's another hint that I would like to share. In addition to using unsigned instructions, bitwise operators, or bitwise instructions, please make sure that you save the recomputed values of mz and mw back into the main memory once you are ready to return from getRandom. Now let me show you where you'll find these special instructions in order to implement random in range and get random functions. They are all in ECPE 170's web page. In lab number 10, there's a link to MIPS instruction set, and this is a partial list of MIPS 32 instructions. You can scroll down and observe that you have all these different kinds of instructions. So for unsigned operations, for arithmetic with uint 32 underscore t variables, you are going to use unsigned operators or unsigned instructions like sub-u. Please make a careful note of how the result is stored or where the result is stored and what is the order of the operands. You'll use instructions such as mul for sure. So you'll use mul. So please make sure that you understand how mul works. You'll be using divu instruction, specifically with respect to dividing values that are unsigned integers. Make a careful note of how the results are being stored. So for example, the quotient is stored in the low register and the remainder is stored in the high register. The dollar high and dollar low, they are not accessible directly, or usually you cannot access them directly like how you would access other registers like S registers and T registers. Instead, there are special instructions with respect to moving values from these registers, and those are MF high and MF low. So for example, MF high, it moves the value from the high register to whatever register that you specify for this instruction. MF low works the same way. So should you require to extract the remainder from a division operation, you need to use the MF high instruction. And should you need the quotient, you will use MF low instruction. You can also find the various bitwise instructions on this page. So let's see where those are. I'll just do Control F. Okay. Let's say SLL. So there you go. So shift logic left or shift left logical instruction is right here. So you'll be using these instructions, shift left logic and shift right logic in your implementations. So please pay careful attention as to how they work. At this point, I have introduced you to sufficient number of instructions for you to pick up new instructions on your own. One of the skills that you will develop as a software engineer is to read the documentation and acquire the skills on your own once your manager or your trainer has given you a head start. Okay. So those are the hints that I wanted to share with you with respect to the implementation of these randomization functions. The next part of this lecturette is going to highlight what kind of errors programmers can run into should they not utilize stack appropriately. So let me reopen the example that I had shared with you in my previous lecturette, a full-blown example that covers how to use stacks for functions and how to use function stubs appropriately in order to produce or write a program that is absolutely error-free. So let me open that example one more time. Okay. There are numerous ways in which programmers can make errors with respect to stack. One of the ways is not to use the stack arithmetic appropriately. For example, instead of adjusting the stack in this manner, if I were to do some other incorrect operation like this, and if I were to also pop using the same arithmetic, then I may get some errors in my code. So for this example, what I did was I performed the stack pointer adjustment in an incorrect manner. So let's see what's going to happen if I were to not adjust the stack in a proper manner. For my own sake, let me remember the line numbers where I made the changes. So on line 63 and line 65, instead of subtracting the stack pointer by 4, I add the value 4 to the stack pointer. And let's see how your QtSpim is going to react to this artifact. So I will reload and reinitialize my problem or my code, and then I'll hit, this is my text section, and I'll hit enter. And it seems like everything has worked okay for somehow. Okay, let me give it one more try here. Okay, so for some reason, it seems like the previous, that small artifact has been bypassed somehow in my code, but you may not be always lucky in that respect. So please make sure, however, that you adjust your stack pointer appropriately. That is definitely an artifact. You may get around it, but that's not good coding practice. You should always make sure that your program works for all possible cases. Let me introduce some other artifact here, and that artifact is what happens if I do not push my array register. So let's say that I forget to push the array register inside init array function. If that were to happen, let's see what happens. What would be the case with respect to Qt simulator. Okay. All right. This time it has given you this error that an exception occurred at PC 0040000D8. So I'll press OK, and I find that there's some sort of an unaligned axis of values at this particular address. I press OK again. Again, the exception occurred there, which is the location 0040008D. So I'll look into that instruction and find out what the problem is. So that instruction is somewhere here, 00D8. So this is the instruction where my program appeared to be breaking, but it really doesn't tell me as to what the problem is. I'm not sure why it's giving me a problem for SW $V0 $0 S1. Most likely that $S1 is not storing a proper address. So let me check it. Well, the address at S1 is this one right here, which looks like reasonable, but is that a fact? I need to verify whether it is indeed the correct stuff. If you notice, here in this statement 101, let's see what we were originally trying to do. We were trying to populate the array values. And it seems like I am trying to write to a location 7FFFF 9FA. I can find out whether or not it is a proper address or not using two hints. Hint number one, I'll ask myself whether it is a really large address value. In this case, it is indeed a very large address value. So I explore hint number two, and that is I'm going to look into my data tab to find out where the user data segment is. So this is the user data segment. This is the segment where my values have to be placed. Remember, in that line, 101, I was trying to access the array location, and my array has to be stored in the user data segment, meaning my array address should have been one of these guys, correct? It should have been one of these guys, but instead it is this large value 7FFF 9FA, which happens to be a location in user stack. So something really fishy is going on with respect to the usage of $S1 register. What I could do is I could backtrack to see how S1 was computed. S1 was definitely computed using S0, and it gives me a hint that S0 was not retrieved in a proper manner, because even the value of S0 is, well, for some reason it's 0. So as you can clearly see here that if you do not use the stack appropriately, you may run into a problem with respect to your code that may be difficult to track. Let's see what other hints we can explore to identify why we got such an error. The other hint is the value of the program counter. Let's look into the value of the program counter, and that is 8000 something, a large value, and it is highlighted right here. It is highlighted right here in the kernel text segment. That's really weird. Your program should not go to the kernel text segment. Why should it go there? That seems unnecessary. It drops me a significant amount of hint that something really bad is happening to your array register. And that's why somehow when you executed JRRA, your program counter suddenly came to this location kernel segment and it did not know what to do next. That's how you can identify such errors with respect to your incorrect pushing and popping onto the stack. So remember guys, please try to use the stub for the functions. Whenever you write a MIPS code with function calls, make sure that you place the stubs for callee functions. Make sure that all the S registers that are, or rather make comments in your callee stub that you need to push the S registers that have to be or that are actively used by its immediate caller. Definitely put the code to push the RA register. This problem this problem arose due to not pushing the RA register. So let me fix that error one more time. So I made the changes here. So I'll fix these two errors, and I can rerun my code. And I rerun my code like this. In this case, you can notice now the value of S1 is 10010024, which corresponds to the data segment. So I'm not changing anything in my stack anymore, or I'm not inaccurately accessing my stack, user stack. So that's the correct execution. Okay, so this was the primary motivation for this lecturette. I wanted to give you some hints to implement the randomization functions, and I wanted to also cover what could possibly happen if your code does not manipulate stacks properly. The biggest, or rather one defensive approach would be to work with stubs of the functions. Make sure that before you start inserting your code in these stubs, make sure that your stub is correct. If you ensure that, I'm confident that you'll get your codes working properly in 1 or 2 attempts. All right, so that's all I wanted to discuss in this lecturette. I hope you enjoyed this lecturette video as well. I hope the hints that I have given you in this lecturette proves useful when you implement the randomization function and when you navigate your way through implementation of functions using stacks. For anything else, please do not hesitate to contact us. Slack channel is the best way for you to contact. We are quite responsive on Slack channel, and should you require anything, please drop in a message there. Happy coding!